Hello friends, we'll discuss today the most interesting and important topic, that is energy conservation opportunities in pumping system. Now, what is the requirements for the energy efficient pump? In industry's major running cost or operational cost, also known as Opex, is due to use of transport of fluids, utilities from one point to the user points. For the same pumps are used in the system, selection of the energy efficiency options can reduce the cost by 40% or more. So what are the energy saving opportunities? Let's discuss quickly. Ensure adequate NPSH required and available at site before installation. Selector must try to match the user requirements using system curve and select the pump which can satisfy the user needs as closely as possible. Operate the pump near best efficiency point. The best efficiency point is the pumping capacity at maximum impeller diameter, which also refer as the point at which the efficiency of the pump is highest. All points to the right or left to best efficiency point have a lower efficiency. Next is use of VFD. The pump performance parameters like flow, pressure or head and power are directly dependent to the speed of the impeller. Flow rate, Q, is proportional to the rotating speed, N, head, H, is proportional to the square of the rotating speed. Power, P, is proportional to the cube of the rotating speed. So, practically, if we see from this equation, doubling the rotating speed, power consumption increased by 8 times, and simultaneously small reduction in speed will result in large reduction in power consumption. This is the base for energy conservation in pumps, where use of variable speed drive will reduce Opex drastically and much more better option than use of control valve. Modify pumping system and pumps losses to minimize throttling. Stop running multiple pumps. Add an auto start for an online spare, or add a booster pump. Operating 2 pumps in parallel and turning one of when the demand is lower can result in significant energy savings. Pumps providing different flow rates can be used. Parallel pumps are an option when the static head is more than 50% of the total head. Avoid pumping head with a free fall return, gravity. Use siphon effect to advantage. Siphon effect is as long as a pipeline is flowing full, the pump head required to maintain flow is equal to the head due to friction and the elevation increase between the pump discharge and the pipeline discharge. This rule holds true even if some point in between has an elevation greater than that of the pipeline discharge. Repair seals and packing to minimize water loss by dripping. Regular preventive maintenance can reduce the operation cost majorly and useful for the enhanced preformation of pump. Optimized number of stages in multi-stage pump in case of head margins. Reduce system resistance by pressure drop assessment and pipe size optimization. Replace old pumps by energy-efficient pumps. That's the summary for the energy-saving opportunity for the pump system. Please subscribe and like the video for further update.